Hello, my name is Chen from NTU Singapore. I'm focusing on autonomous driving and robotics.
We propose Tracer, an onboard force-sensitive resistor array-enabled thrust auto-calibration and ground effect estimation approach for multi-rotors. Current research on thrust coefficient calibration and ground effect estimation mainly requires the experiment, platform or motion capture system with dynamic iterations for bench tests. Thrust mapping based on bench tests is static. Slight differences in the environmental factors and intrinsic conditions cause the need for a calibration. At the beginning of each flight, there are some proposed in-flight calibrations, but still a good static initialization is required. Other state-of-the-art solutions are based on optimization, which may calibrate the thrust with only one flight test, but the ground effect is not considered. Thrust calibration and ground effect on the rotor are highly coupled issues. These two problems are usually addressed separately. Here, we present Tracer, an onboard force-sensitive resistor array installed under the landing gear of the multi-rotor and corresponding algorithms to enable the thrust auto-calibration and ground effect estimation simultaneously. Here is the framework. Contact force detected from the FSR array reveals the relationship between control, input, and thrust when the quadrotor is in contact with the ground. We collect flight data during the liftoff phase, processing it within 3 milliseconds with only listed configurations, and then get the calibrated results and decouple them to the free air thrust coefficient and ground effect constant. Please refer to the manuscript for the details of the formulation of this problem. Experimental validation approaches are designed to validate the effectiveness of our proposed method in the application. It happens mainly in the out-of-contact phase with ground truth from the mocap system. The generated estimation of free air and joint estimation are compared with the ground truth separately with respect to given metrics. Here's the example of the design of our experiment. When the quadrator is in contact with the ground, the control inputs and contact force will be collected. Once takeoff is detected, it will be processed within 3 milliseconds with Tracer. Then the calibrated values will be used to estimate free air and joint thrust in flight. This process can be validated by the mocap ground truth. Here are more experiments conducted and evaluated with the metrics during the tests. The experimental results demonstrate that the proposed method provides reliable joint calibration and estimation of rotor thrust and ground effect simultaneously in a short liftoff process, achieving less than 10% mean absolute percentage error compared to the ground truth. In future research, Tracer is able to be applied to multi-rotors with high-precision operational requirements, while remaining compatible with other in-flight estimation approaches. Thanks for watching.